Hello everyone, welcome to our podcast session.
We, your hosts, Naman and Shiva, are joined with Darshan and Samagra, and today we are diving into a fascinating blend of technology and strategy, the auction house simulator using data structure.
I am Darshan, and thank you very much for inviting us to this podcast and allowing us to speak about our smart auction house. Traditional auction houses are often intimidating and unapproachable for many. Most auction houses are for auctioning super expensive items like rare paintings or other valuable items. They require strict dress codes and connections, and some don't even allow you to enter them. This is where our smart auction house comes in. It provides a platform for both auctioneers to auction their items or their work and bidders to bid for items they usually cannot find at traditional marketplaces. It is a simple, user friendly, and approachable system where you can use it even at the comfort of your own home. Next, we wanted to decide how we were going to actually implement the system. So to design and to design and simulate an auction house where users can be both auctioneers and bidders. Auctioneers can list multiple items in the auction house for bidding, with each item having its unique name and description. Bidders can bid on any items using the unique item name and keep track of their bids. Next, I wanted to talk about the objectives and the applications of our system. So our system provides a platform where users can participate in multiple bids simultaneously. It will update the highest bids in real time and show the results of the auction of each auction to the bidder, so they know which bid is placed in which auction. Auctioneers can auction multiple items, with each item having a unique name through which it can be easily accessed. Our system also has baked in security features, which ensures that the highest bid always wins using a priority queue. Tiebreakers based on which bid was placed earlier is also decided, and it automatically decides the winner and closes the auction. Some of the applications of our online auction system are that it has many benefits. As there is no requirement for a physical place, it's more accessible to the common folk to bid and hold auctions. It can be integrated into online marketplaces to sold unique items which are not traditionally sold in marketplaces. It can be charity organizations can use it to auction certain items to raise funds. Next Samagra will tell us how our auction system actually works.
So for the handling of the actual auctions, the data structure used is priority queue, which we have implemented using a max heap. This we preferred over the traditional linked list priority queue as it allows for faster operations such as you can insert an element within O of login and you can access the highest element in O of 1. Other than this, a map is also used, which essentially helps keep track of all of the user data and store all the auctions that are currently active. So let's have a look at the code. So here at the top, so we have the implementation of all of these data structures, which I have just talked about. Uh, let's get into the features of the auction house system. So we have a lot of features. The first one is that it allows the users to create an auction. This essentially works by initializing a priority queue within the system, and it stores it, and basically it maps it to the name of the auction, right? And then the other feature it allows you is that it allows you to place the bid on the auction. This creates an entry within the user and within the user data structure, and it allows you to place the bid. It creates an entry of the bid that you placed on an auction, and it also adds an element to the priority queue of that auction. This hierarchical structure of the priority queue essentially helps us decide the winner. Now, the next function of the auction house of the system is that you can view your auctions. This is essentially iteration through the map, and it prints out all of your active auctions. Then you can also view all the auctions that are currently active within the system. This prints out each of the auction items that are currently active along with its owners. You can also view your bids. So this will just display all of your all of your current bids that are on active auctions. Then you can also view the bid history of auctions that are currently active. This will display the hierarchical structure and it will show you which bid is currently winning. Then you can view the balance of your balance. You can only view your balance to help protect user data. And yeah, then you can end the auction. This essentially automatically handles the deletion of the auction from the system. It also handles the deletion of the entries that were made when you placed a bid on that auction item, and it also handles the deduction of the value of the bids from the users and the refunds wherever applicable. Essentially, the winner would have their amount deducted, their bid deducted from their balance, and the owner of the auction would get that amount. And all of the others who placed bids but their bids did not win would have the amount refunded to their balance. Then the last function we have is that you can switch your user. This essentially allows you to interact with the system by creating an auction from one user and bidding on it from other users within the system. Now let's run our code. So in order to initialize the system prompts you for the number of users that you want to create within the system. So here, let's say I will create 3 users. I'll name them Samagra, give them a balance of 1000, and so on. Now it prompts you which user you want to log in as. So let's say I log in as Samagra, and I create an auction. I call it painting. And then I can switch my user to, let's say, Darshan, and I can place a bid of let's say 100 on the auction painting. So I would have to provide the name of the auction and then the bid amount. Now, if you look at my like as Darshan, if you look at the active bids by viewing your bids, then you can see that you have placed a bid of 100 on the painting. You can also view your auctions, which as Darshan, there are no active auctions. But if you view all the current active auctions, then you can see that there is an active auction called Painting owned by Samagra. Then you can also place, let's say I want to place another bid from a different user. Let's say Naman wants to outbid Darshan and he places a bid of, let's say, 300 on the painting. And then you can see that bid would also be placed, as you will be able to see from the view my bids. Okay. Now you can also view the bid history of the auction. So that would look something like this. And you'll be able to see that currently Naman is winning with a bid of 300. Let's say Darshan decides to match this bid and he also places a bid of 300 on the painting. So you will be able to see that the bid of 300 was placed successfully. And now if you have a look at the current bid history of the painting, then you will see that Naman is still winning because Naman placed his bids before Darshan, even though they are the same value. So now let's switch back to Samagra and let's end the auction. So let's end auction painting. And here you can see, congratulations, your painting was sold for 300 to Naman. Now this balance will be reflected. So as you can see, Samagra's balance was just increased by 300, which is what he sold the painting for. The balance of Naman will have 300 deducted, as that's what he had bid on the painting. And as you will be able to see, Darshan's balance will remain unchanged because his bid was unsuccessful. So that's about the simulation of the program. Now let's go back to the PPT and talk about the test cases that we considered for this program. So just going through the implementation, and yeah, so this is the test, these are the test cases that we had taken care of when we were creating this program. So first test cases, we basically we took care of a lot of test cases, a few of which were: you cannot place negative bids, you cannot place a bid that is lesser than your last bidded amount, because obviously that would not make sense. You cannot place bids on an auction that does not exist. You cannot place bids on your own auction. You also cannot essentially bid higher than your balance. It'll also check for that. So yeah, in this way we have took care of all the test cases that we came up with. Now Darshan will talk about the plagiarism report.
Thank you very much. So our auction house system also has scope for improving in the future, like adding adding a user-friendly GUI and also baking some security features to protect user privacy. Now, coming to the plagiarism report, this is our plagiarism report. We have a 10% overall similarity, and these are the references used to help build our auction house. So, thank you very much for inviting us and letting us talk about our auction house. Do you have any questions for us?
Thank you, Darshan and Samagra, for your insightful session on this podcast regarding your online auction house system. Now, moving on the questions, I really got questions as well. My first question would be: in real world online auction systems, fairness and transparency is a real issue. How does your system exactly simulate and address this problem?
So as I explained during the simulation of the program, we have created this hierarchical structure that basically prefers the highest bid first, and then if there are multiple bids of the same value, which are both the highest bids, then in that case it will prefer the bid which was placed earlier. In this way, we have kind of created this hierarchical system which allows fairness. And talking about transparency, you can view the bid history of any auction at any time, which will essentially display the hierarchical structure to you. It will show you which bid is winning. And yeah, so that's how we have taken care of that as well.
Okay, I also have a question. My question is, how could artificial intelligence or machine learning enhance your auction house in the future?
Okay, we have actually considered adding this feature in the future. Machine learning algorithms could analyze past bidding patterns of users and predict starting prices for new auctions. So it will help the user to place an optimal bid. AI could also be used to detect unusual or fraudulent bidding behavior to enhance security of our auction house system. Thank you.
Alright, data privacy is important. How would you prevent or protect bidder information in your near future?
So thank you, Naman, for this question. So we have tackled this issue by essentially leaving no record that an auction has taken place. How this works is, after the auction has ended, basically once you run the function to end the auction, it gets rid of all of the entries of that auction, whether that be the bids placed by the users on that auction or the auction's entry itself. So it gets rid of all of these entries. The only thing that remains is a change in balance of the users. It only reflects the transactions.
I also have one more question. My question is, how do you ensure that your system cannot be exploited by fake bids or repeated submissions?
Okay. Our system checks whether the bid amount that is placed is higher than the current highest bid, or whether the user even has enough balance to even place the bid in the first place. So if either of the condition fails, the bid is rejected automatically. So using this, our system ensures that it cannot be exploited by fake bids or repeated submission, which can hinder the auction. Thank you very much.
Alright, Darshan and Samagra, that was a really insightful presentation on your online auction house system. We really enjoyed to have you on board in a podcast session. Hope for good things in near future. Thank you.
Yeah,
Thank
thank
you.
you for
Thank you
joining.
so much for having us, guys.
Hello, everyone, and welcome to our podcast where we explore how data structures can be used to simulate a stock market. So we are your hosts, Samagra and Darshan, and we are joined by Naman and Shiva, who will be talking about their fascinating application. It's a blend of technology and finance, uh, a stock market simulator.
Right, thank you, Darshan and Samagra, for the wonderful introduction. And we are glad here to join you as well today. So, let's get things started. So, our project is a modern stock market trading simulator. It replicates real market behavior using continuous double auction system. It matches buy and sell orders in real time using price time priority rule. It is built in C. It has features like real time order matching, trade tracking, and market depth visualization to mimic real world trading. Yeah, so for this project, we use four main data structures, that is stack, queue, heap, and linked list. The stack helps us undo and redo operations by tracking with most recent trades using a last in first out approach. The queue manages incoming orders in the order they arrive, ensuring fair first in first out based trade execution. The heap keeps orders sorted, allowing quick access to top bids, and asks for real time matching. And finally, the linked list maintains trade history dynamically, letting us easily add, modify, or traverse trades for analysis. Our implementation process begins with defining core structures for orders, stock, and trade history. It stores details like price, quantity, and timestamps. Next, we handle user inputs for stock type, price, and quantity and place them into the right data structures based on priority. Then the trade matching system compares the highest buy and lowest sell orders and executes trades when prices align. And lastly, we use tag based undo and redo mechanism to reverse or reapply recent trades, ensuring flexibility and accuracy. I now hand over the presentation to Shiva and he'll present the code analysis.
I thank my friend Naman for such a wonderful insight on our project. Now I'll take you through all the coding part of our project. Uh, so the starting part majorly includes defining the data structures, namely stack, queue, linked list, and heap. And we have used predefined stocks, for example, Apple, Google, Tesla, Microsoft, and Amazon. And as you can see, the main part of our code, main part of code of project is placing an order, undoing the latest order, reading the order, and viewing the trade history, seeing the market depth of the product. So here the main project starts. So the first function being the place order. Here the user enters. Here the user enters if he or she wants to buy or sell the stock. Here they will enter like buy or sell, and here we have kept a constraint that if he or she doesn't use the perfect words, like it will return invalid type. And also here they will not only enter their purpose, that is buy or sell, but also the quantity and price of the stock. Uh, uh, this will be stored in the link list. And second function being undoing the trade. If the user wants to undo the last trade, then this function will undo the trade using here we have used stack function, and this is the redo. If someone might have accidentally deleted their transaction, he or she can redo the trade too. Like if someone must have accidentally press the undo button, like he or she can do the redo thing. And then view trade history, view history, this function. This is the linked list part of our project. Here here the one can see the trade history. If the trade has happened or not, one can see in this function. This function returns that. And also after undoing or redoing it, it shows the updated version as well, that has the trade happened or not. Have used heap. Here it checks the here it automatically checks the best price for the stock if someone wants to buy it. And this is the market there. I'll show you one demonstration too. For example, we have so these are the various test cases on which we had tested our model. Example, partial trade, basic trade execution, no match, and I have already shown through demonstration all these various test cases. And these are the result. Though I've already shown, I've also included screenshots in the presentation. And yeah, it's done. Now my friend Naman will continue.
Yeah, so thank you, Shiva. It was a very good presentation on the code. So our project makes stock trading simpler and smarter for everyone. It helps you track trades, fix mistakes easily, and supports new technology in finance. Moving on to the future enhancements, we aim to grow with even better trading tools and a friendlier experience for users in the future. So this is a plagiarism that we have generated through Turnitin. Our project shows 10% overall similarity according to the software, and all the necessary details are mentioned as given in the slide.
So here we end. Thank you.
Yeah,
So Samagra and Darshan, if you have any questions, yeah, you are
Yeah.
free to ask.
So So I have a question. Why did you choose to use a heap data structure for matching buy and sell orders instead of using a simple array or list?
Yeah, it's a great question, Samagra. I think that I have already explained this. Heap allows efficient retrieval of the highest or lowest element in O of one time and insertion or removal in O of many. So in a stock market, the best trade always happens between the highest buy and the lowest sell prices. So using a max heap for buyers and a min heap for sellers, it guarantees that the best price are always at the top, much faster than searching through an unsorted array or list. So I think this answers your question.
Next, I have a question to ask. How do Stack and Queue together improve the system's functionality?
yeah. So it's a great question, Darshan. So I think the queue ensures that all the new orders that are processed are in the exact order that they arrive. It follows first in, first out method. We have already explained that, but it maintains market fairness as well. So and stack, however, it provides a LIFO access for executed trades, enabling undo and redo features. Right. So together they model two different real world flows, and sequential order handling is handled through queue, and reversible user actions are done through stack. Yeah, so that will be your answer.
Oh, so I have a follow-up question. How can you integrate the queue and heap more effectively if your simulator were scaled to handle thousands of orders per second?
Yeah, another great question, Samagra. Let's answer it by saying that this is just a basic prototype. This is not the final model. But what I'm thinking is that in the future, what I would do is like I would maintain a queue of all incoming requests and use separate heaps for stock. And also a scheduler thread would dequeue each request and put it into appropriate heap. This separation maintains the FIFO processing while also using heaps locally for optimal trade matching. It also ensures scalability and reduce contention. I think so. This answers your question.
I have one last question to ask. What real world improvements could be added to make the simulator more realistic?
Yeah, so thank you for this question, Darshan. It sees a broader prospect. So, as mentioned, the possible enhancement include adding a real file database storage for the order data, and for it to support multiple stocks and users concurrently. It can only handle one user at once for now. And we also plan to introduce threading to simulate real-time order flow, and implementing market analytics like average price, total volume, or volatility tracking. These features would make the system more reflective and an actual exchange platform. Yeah, thank you for the question, Darshan.
Wonderful. That was an incredible stock market trading simulator. That was really insightful and shows how you use the data structures to simulate and implement this. So, thank you very much for showing it to us. And we hope that it performs well.
Yeah, thank you,
Thank you.
Darshan Samagra, for
Thank
having
you,
us
Darshan and Samagra.
and providing us a platform to showcase our project. Yeah, thank you.
You're welcome.
Thank you.